This is Christy Fowler from Yadkin Early College. This is for Math 3, Inverse Functions and Logarithms. Okay, so we've been talking about functions, and what we're going to talk about today in this video are how to find function inverses. Okay, we've talked about inverses before in different aspects. So remember, like we've done the inverse of cosine, we've done the inverse of sine and tangent and that sort of thing. So what we're going to focus on now is just finding the inverse of certain functions, because that's going to lead us into finding inverses for logarithms, because logarithms are inverses of different things. Anyway, alright, so here we go. So remember, for a function, for each x there's a unique y. Remember we drew the input and output function machine today in class, so you input an x, it outputs a y. So for an inverse function, all you do is you switch the x and the y. Okay, so you switch that x and that y and you've inverted it. So the example that is on your screen right now is the inverse function of x squared. So we start off with the original function, x squared. You can see that makes a nice pretty parabola. Alright, the inverse of that, remember the notation for the inverse is f to the negative 1 power. That tells us that's the inverse function. So the inverse of x squared is the square root of x, and the square root of x, when you graph it, looks like so. Alright, so when we're given a function and someone wants us to find the inverse of that function, there's a little bit of algebra that we have to do. Remember, I told you that we switch the x and the y. So that's your first step for finding the inverse of a function. If we're given a function, f of x equals negative 3x plus 4, and we want to find the inverse, we're wanting to find f to the negative 1 power of x. Alright, so we start with our original function. You'll notice that I have replaced the f of x with a y. That's so we can switch that x and that y value. Okay, so that's all I've done first. Then I switched the x and the y. Where the y was is now an x, and where the x was, there's now a y. And the whole goal here now is to solve for y and get y by itself again. Alright, so the first step you do is you subtract 4 from both sides. This is just basic algebra and solving equations, okay? So we get x minus 4 equals negative 3y. Getting y by itself, we have to divide by negative 3. And what you do to one side of the equal sign, you got to do to the other. So you get x minus 4 over negative 3. And now we have y by itself. And you're done. Okay? So the inverse of that function, negative 3x plus 4, is actually x minus 4 divided by negative 3. Now that leads us into logarithms. Logarithms, excuse me. So shortened logarithms are just logs. Anytime you hear a mathematician talking about logs, they're not talking about going out into the woods and running over those things that rot in the ground and stuff like that. We're not talking about logs like that. We're talking about logs as in logarithms. Logarithms are inverses of exponential functions. Okay. So if you're given that y equals b to the x power, that is standard form from an exponential function. Alright, so if y equals b to the x, then when you want to write it in logarithm form, it's log base b of y equals x. So you'll see y is still in both equations there, b is in both equations, x is in both equations. And they have relative places too. So even though it's the inverse, the logarithm is the inverse of that original exponential equation, they're still in similar places. When you read this out loud, as I just read it to you, log base b of y equals x. Now, an example of this. So if you're given the exponential equation 25 equals 5 squared, okay, then log base 5 of 25 equals 2. So you'll notice that 5 in the red here is the base for that exponent. So it's base 5, 2 is the exponent. Alright, well over here in the logarithm, 5 is also your base number. log base 5 of 25. So you see there's your 25 again. It reappears over here. And your exponent of 2 also reappears because log base 5 of 25 equals 2. Alright, so of course you're going to have to evaluate a log and rewrite it in exponential form. So you start with log base 8 of 16 equals x. We want to solve for x. Alright, so the first thing you do is rewrite it in exponential form. Okay, so you take your base from your log, it becomes the base of your exponent. Okay, of 16, remember in our last slide there, of 25, so it equals the 16 here. Okay, the next thing you do is you rewrite it so that has common bases. Both sides of your equation have common bases with an exponent form. Okay, so since 16 is can have a base of 2, okay, with an exponent, 2 to the 4th power gives you 16, and 8 can also have an exponent form with a base of 2, that's 2 to the 3rd power. You're going to rewrite it so you have the base of 2 for both numbers. So 16 is equal to 2 to the 4th power, 8 is equal to 2 to the 3rd power. It's important to break it down so that the bases of those two exponents on your equation have the same base. Alright, the exponents, we'll deal with the exponents in a minute. Alright, so 8 is 2 to the 3rd power to the x power. Alright, so when you rewrite it without the parentheses, you've got 2 to the 4th equals 2 to the 3x power, I guess you'd say. Alright, so then you just take your exponents down, because we're kind of, since they have the same base, there's really nothing else you can do with that. All we can do now is work with those exponents. So really all you have to do is take the exponents down, so you've got 4 equals 3x, and solve for x. Divide both sides by 3, 4/3 equals x. So log base 8 of 16 equals x, it equals 4/3. And the last thing that you got to know from this video is common logarithm has a base of 10. Base of 10. Alright, thanks. See you later.